Okay, so for the last 3 days, we've been looking at combination of functions, and we've been adding or subtracting them, or even multiplying them. And that way of combining functions is one way of doing it. Composite functions is another way to combine them, and we'll look at those. And this is where one function actually becomes part of the other function. It's inside the other function. We've done a bit of this before, and you've seen this before, so just a little new notation today, and a review of an idea. So what we're going to do is look at these two functions, and I've given them different names. The f function, which is just a quadratic, x squared minus 2, and a g function, which is a line, 3x minus 1. And so we're going to combine them through a composite this time. Instead of adding them together or multiplying them together, we're going to combine them through a composite. And we're going to ask you to find what f at g at x is. And the way this notation works is you look from the inside out. So the g at x here is now the thing that you are substituting into the f function. Normally on these ones I would ask you something like, find me f at 3. And f at 3, you would take 3 and plug it into the f function. So you would take 3 and plug it right into there and find out what that is. When you're doing a composite function, though, you're not plugging a number in, you're plugging in another function. And that has its, that's how it's a little different. So I'll just backtrack here. And so if I'm going to ask you to do f at g at x, you're actually going to substitute the g at x function, which in this case is 3x minus 1. And we're going to take that and plug it right into the f function. So wherever we see an x, we're going to replace it with this whole thing. So the function used to be x squared minus 2. So that x gets replaced, instead of with a number, with the g function. So it'll be 3x minus 1 squared instead of x squared minus 2. Now you can go off and simplify. 3x minus 1 squared. Remember, don't do that grade 9 mistake and say it's 9x squared minus 1. 3x squared minus 1 squared is 3x minus 1 times 3x minus 1. And then rainbow it all out. So that's 9x squared minus 3x plus 1. And then that minus 2 hanging around at the end. Combine your like terms. 9x squared minus 6x minus 1. And your answer is actually a brand new function. So when you take the composite of two functions, you're creating a brand new one. So you see the old one was, there's your f at x one, there's your g at x, and the composite of those is this brand new function, which has some characteristics of the first one and some characteristics of the second one. Okay. Now I could ask you, find f at g at negative 1. So a couple of ways you can do this. Here, again, you work from the inside out. So if you look inside, you have g at negative 1. So that part says, keep the f the same, but g at negative 1 means you take negative 1 and you plug it into the g function. So wherever you see an x, you replace it with negative 1. So it used to be 3x minus 1, so now it's 3 times negative 1 minus 1. And what I'm doing inside the brackets is only doing the g at negative 1 part of it. So that little part of it is 3 times negative 1 is negative 3 minus 1. And g at negative 1 is negative 4. Now you get this negative 4. That's the inside part. That's this part right here. G at negative 1 is, turns out, is negative 4. And now you get that answer of negative 4, and you take it and plug it into the f function. So wherever you see an x, you're going to replace it with negative 4. So it used to say x squared minus 4. and so now it's going to be negative 4 squared, or not minus 4, minus 2. And then this math is negative 4 squared, which is 16, minus 2. And we get that f at g at negative 1 turns out to be 14. So that's not the only way of doing this question. Because in this particular warm-up, I asked you to find this function in general first. I asked you to find the f of g at x function. And it turned out the f of g at x function is this. So if I ask you the f of g at x function, but you're subbing in negative 1, you can actually sub negative 1 right into this function. And you should get the same answer. So since we already know f of g at x equals 9x squared minus 6x minus 1, we know that from A. If we were to find f at g at negative 1, we can plug that right into this function. And hopefully we'll get the same 14 answer. So let's do this. So that's negative 1 squared, which is positive 1, times 9, which is 9, minus 6 plus, times negative 1 is plus 6, and then minus 1, so that's 15, minus 1 is 14. Oops. And it does work. Now, can you see advantages or disadvantages of either of these? Don't be shy.
The advantages are that it's easier and quicker to plug it into the function you already have.
That is, if you don't already have the equation to plug it into, then you might as well just do it the other way. So instead of going out and finding it.
Then B would be easier.
Mm. Mm-hmm.